today we will be starting the next topic, the most trickiest one in the entire course, that is pointers. This is not part of your minor exam, but we'll be moving on to this topic. We'll be spending sufficient time on this topic. Yeah. So before I explain this concept, let me give you an example. We'll discuss based on that. Suppose I want to, this program you did in one of your first few labs itself. Suppose I want to swap two variables, right? Say x equal to 5, y equal to 6. What do we do? Yeah, one way is we use a third variable, say temp. Now, no, if you're adding and all that, you don't need a third variable. Yeah, let's say temp equal to x equal to y, and y equal to temp, right? Now, let us print these values before swapping and after swapping. Before swapping, value of x and value of y, and after swapping, value of both the variables, right? So before swapping, x is 5, y is 6. After swapping, x is 6, y is 5, right? This we all know. Now let me try to put this code inside a function. Say, suppose I want to do swapping many times. There are many variables and I might need to use swapping multiple times. Then every time I don't want to repeat these 4 lines or the 3 lines always. I want to put this code in a function and I want to call that function as many times as I want, right? So first I'll define a function, say swap, because this function will not print anything. It just swaps the variables, right? So it will take 2 integers. It should swap them. And I'll put this code inside the function. All right. I will just need to call this function in the main function, right? Yeah. Now, no matter how many times I want to swap, I'll just call this function, right? So this is the function for swapping. In the previous code, this is the code for swapping. So this code for swapping, I put it inside a function and I'm calling that function. All right. So now when I run this, you see, before calling the function and after calling the function also, the variable values remain the same. They are not swapped, right? The function took the variables, it actually swapped them, right? It took x and y, it swapped them, but when you came out of the function, the variables are not swapped, the values are not swapped. Why? Yes, exactly. So what the function is doing, it is swapping the copies of x and y, not the original x and y. All right. So whenever you pass some data to a function, it always copies it and works on the copy. It does not work on the original instance. So although the names are same, it doesn't matter whether the names are same or different. So this x and y are different from this x and y. This x and y are copies of this x and y. They are not originals. So you can as well name them as x dash and y dash. So whatever it is swapping x dash and y dash. The original x and y remain the same. Okay. So now how do we solve this problem? Global variables. All right. Global variables can be one option, but I don't want to use global variables. You see, 1 minute, even if you use global variables, once you pass them to a function, global variables will not be swapped. Local variables will always override the global variables. Okay, so one option, what he's saying is you can return the values from the function and then sort of catch these values in the main function when you call the swap function. Okay, so if I have to return, what do I write? Return x comma y. And here, what should I write? Int. Suppose I have two other variables, say cat c1 and c2. Suppose I want to return them as well. Then here, what should I write? Int comma cat. Can I write like this? No. Then, if you can't return one integer and one cat, then how can you return one integer and one more integer? You should actually then write int cat, right? Two integers, two characters, again you may return an integer, again you may return some float. You need to give each data type, right? But it doesn't matter whether character is also integer or not. Instead of character, suppose if I give float, is that okay? It's not about same data type or not same data type. It's about how many variables you are returning. Even if they are all of the same data type, you cannot return more than one variable. That's it. You cannot return more than one value. You see, these functions are very similar to mathematical functions. In mathematical functions, what is the definition? What is the difference between a relation and a function? What? Function. Not exactly correct. What is the difference between a relation and a function in maths? Set theory, sets. What is a relation? What is a function? Huh? When you say relation maps two sets, it maps elements of one set to elements of another set. It doesn't map at set level. It will still map at element level only. So then what is the difference between relation and function? Yeah, you are somewhere, shooting in the dark. Some things are hitting, some things are not hitting. Yeah, exactly. A function is a kind of a relation, but it should satisfy conditions like every element in the domain should map to some element in the range, and no element in the domain should map to more than one element in the range. There can be many to one mapping or one to one mapping, but one to many mapping is not allowed in a function. If it is one to many, it becomes a relation. It's not a function anymore. All right. Simply putting, a function can take more than one input, but it will give you always only one output. A relation basically relates multiple entities to multiple other entities. That's the difference. Similarly here, a function, a programming function, it can take many arguments as inputs, but it will return only one output. So if you want to return, you can return only one thing. You can't return two integers or one integer, one character. No two things. Whether they are of same data type or different data type, no two things. Only one thing. It can return only one variable, one thing. That's all. So return option is also not there. You can't return both x and y. It's gone. That option is not there. What are the options? You can't use global variables. Even if you use, it will still work in the same way. The local variables only will be swapped. Global variables will remain the same. You can't use return values because two variables cannot be returned. Then what to do? So let me give you an analogy. Suppose, say, you want to give Supari to someone to kill someone else. I don't know how many of you heard the term Supari. Supari means whatever amount you are giving to that person to kill someone else. Now let's say you want to kill some person A. All right. Now you have another limitation. You cannot bring A to this killer. And you can only sort of you have only one function, or you can perform only one function. You can only, whatever information you are giving, you can give only copy of the original information. You have some data, whatever data you are passing on to the killer, you can only give a copy of the original data. Suppose if there is a person called A, you can send a photo of A to the killer. But if the killer kills the photo, the original A will not die, right? He can't. Photo is some kind of a copy, that's all. Whatever functions he is performing, it is only on the photo. Or what else can you do? You have some information. Other than A also you have some information. Whatever information you have, you can send only a copy of it to the killer. Yes? Address of A. Right? I cannot bring A to the killer, but the killer can go to A. Right? But how do I pass on this information to the killer? By sharing the address of A with the killer. Now this address, imagine you are, say, WhatsApping the address to the killer. You will have one copy in your phone. The killer will have one copy of the address in his phone. But that doesn't matter. Whether it's the original instance of the address or a copy of the address, both of them are pointing to the original person, not the copy of the person. Okay? So giving a copy of the address doesn't matter. But you can't give a copy of the original person, because he needs to act on the original person. Okay, so imagine there is a person A and he has some address. All right, I have a limitation that whatever information I am sending, I can send only a copy. Either I can send a copy of A, maybe it can be a photo, or I can as well say completely replicate A. I can create a duplicate of A and send the duplicate to the killer. By killing this duplicate, A will not die. Right, so that is of no use. It can be photo or a twin or some duplicate, whatever it is. All these are only copies of A. I can only send this to the killer. I can't send original A. Or other option is I can send copy of the address. Now what happens? The original address is pointing to the original A, and the copy of the address is also pointing to the original A. So it doesn't matter whether the address is original or copy. What matters is where they are pointing to. Both the original address and the copied address are pointing to the original person only. So this information is sufficient for the killer to go to that location and do his job. Right? So rather than sending a copy of A, I will send a copy of the address of A, because I'm limited. I can send only a copy. I can't send even original address. I can't send. When I type in my phone, this instance is with me only. I can't send this instance itself to the killer. Some copy will go. Okay, but still that copy is useful. Whereas copy of A itself is of no use, because whatever actions are done on that copy do not affect original A. But copy of address is useful because that copied address is also pointing to original A. Right? Or imagine, say, I want to hire someone to paint a building. That building is fixed. I can't send that building to that person. Nor if I give a photo of that building or an entire replica of that building, painting that replica or the photo will not paint the original building. Right? I need to send the location of the building to the painter. This location itself can be a copy, but still he will go to the correct building. Right? So you have some data and you have address of that data. Whenever you pass data to a function, its limitation is it will not take the original data. It will always make a copy of it. So it will work on the copy of the data, not the original data. So what to do? Rather than passing the data, you pass its address. It will make a copy of the address also, but still this copy of the address is pointing to the original data only. Right? So imagine this is some variable X. This is its address. If I try to pass this X to a function, it will make a copy of it. So the function works only on the copies. This X will not be affected. So rather than passing this X, I will find out its address, pass this address to the function. Now this function will also have access to the original X. Then it will work on the original X. Got it? So that is the simple concept of pointers. That's all. This is all what pointer is. Pointer is nothing but address of a location, address of a variable. It points to that location. That's all. That is what a pointer is. How many of you understood whatever we discussed? What about the rest? You have any specific doubts, or you want me to repeat, or you don't care? At least if someone wants me to repeat, I'll repeat. Otherwise, if you don't care, fine, we'll move on. This concept is important. If you don't understand this, you will not understand the rest of the topic. Yeah. Yeah. So what I'm saying is, imagine, you see, there are multiple ways of creating a copy of a variable. Suppose in the main function, you say int x equal to 5. If the variable is defined inside your function itself, you can work on that variable. Like you can say x plus plus, or you can say x equal to 6 later. You can do these kind of things. But suppose if I map x to some other variable, say y equal to x. Now if I change this y, will x change? Will it change x? No, because y is a copy of x, right? Similarly, if I pass this x as an argument to a function, right? Suppose some function f void f, I pass this x as an argument to this function. This x is no different from this y. This x is actually a copy of this x. So you can as well name this as x dash. So whatever you are doing inside the function will change only x dash. It will not change x. Okay, that is the limitation of a function. All right. So if you assign the variable to another variable, or if you are passing a variable to a function, you are working only with copies. If you want to modify the original variable, either that variable should be within the scope of your function, or you should pass the address of that variable to the function, to some other function. If you want to pass that variable to some other function, it will not go into the scope of that function. Its scope is within its brackets. This variable was defined outside its brackets, so you can't do anything about it. So if you want that function to modify this original variable, you have to pass the copy of its address, not the copy of this variable. Okay, that is the thing. Like here you have a variable. If you try to pass it to a function, that function will work only on the copy of the variable. But every variable will be located somewhere in the RAM. So each variable will have an address. So how does the RAM look? We already saw once earlier. You have series of cells, right? Say somewhere variables are stored. Say this is x, this is y. Say this is 5, this is 6, and each of these cells has an address. Say this is starting at 200. If this is 200, what will this address be? 201. 199. I mean, it is increasing. Let's imagine it's increasing from top to bottom. Will it be 201? What data type is this? Int. How many bytes will int take? 4 bytes. So if this is 200, this will be 204 plus 4. That's all. Right? Because this will take 4 bytes. What are the 4 bytes? 200, 201, 202, 203. Then this will start from 204. All right. Then suppose in the next cell, say I have a character, say A. What will this address be? 208. Exactly. Because this data's size we need. This will occupy 4 bytes. So from 204 to 208. So this will be stored in 208. Next address will be 209. Yeah. Because it will take only 1 byte. Okay. So elements are stored in the RAM at some address. Now the point is, if okay, so before I explain the concept, first let me code it. You'll understand better. I mean, partially you understood. If I pass the variable, it will create a copy. It will work on the copy of the variable. It will not change the original variable. If I pass the address, it will create a copy of the address also, but still that copy also is the address of the original variable only, right? Whether it's a original address or copied address, value is not changing. And both these values are pointing to the original variable only. That's all I need, right? So now what we will do, so we will change the function so that it takes addresses of the integers, not the integers themselves. All right. So let me use different names. We can use same names. It doesn't matter, but I'll just use different names to avoid confusion. So let's say int star A, star B, and within this, we can follow similar logic. I create a third variable. I want to swap not the addresses themselves. I want to swap the values. Keep it aside somewhere. I want to swap the values stored at these addresses, right? So let me write it. You'll understand it. Sorry. First temp equal to star A, then star A equal to star B equal to temp. All right. Now, what do I need to pass to the function? Address of integers, address of x and y, right? So here we write ampersand x and ampersand y. This is the reason why in scanf you use ampersand. We will come there. So that's it. Now I'm not passing integers. I'm passing their addresses. So this function is making copies of these addresses. A and B are copies of addresses of x and y. But still these copies are pointing to original x and y. Okay. So star A, star B. So when we say star A, what it is doing is A is an address. That address is pointing to some variable. So when you say star A, what it is saying is go to that location where A is pointing to and get that value and assign that value to temp. Similarly, when you say star A equal to star B, go to the location which B is pointing to, get that value and assign that value in the location where A is pointing to. Yeah, anyway, let's get back to the topic. So when we say star B equal to temp, whatever value is there in temp variable, go to the location which B is pointing to and override that value with the value of temp. Okay, so this is what is happening. So now let us see if this will work or not. It worked. So earlier x and y were 5 and 6. Now x and y are 6 and 5. They are not modified in the main function. They are completely modified only in the swap function. When you came back to main, the original x and y are also modified. All right. So now you are not returning anything. You are not using global variables. You are modifying the original variables themselves by passing their addresses to a function. All right. Same thing can be done slightly differently. So what we will do, we can assign pointers. So we'll say int star p equal to ampersand x. Similarly, int star q equal to ampersand y. And here we can pass. Yeah. So basically, we will pass p and q. You should not pass star p and star q. I'll explain why. This will also work. All right. So let us see. This will also work. Either you can store the addresses in variables and pass those variables, or you can pass the addresses directly as arguments. Okay, anything is fine. Now, so the point is, say you have some variable in the RAM, you have some variable X, its value is 5, and it has some address in the RAM. Say it is stored at 200. I will just put a subscript A to this to say that this is a number, but this is an address. All right, this is a special number. So this is name of integer variable. This is value of X, and this is address of X. All right. Now I have another cell which stores this value, address of X, as its value. Okay, so its value is 200 subscript A, and let's say this name is P, the name of this cell, and this cell itself will have some address in the RAM. Let us say that is say some 1000. Now this will be address of address, right? P itself is an address of integer. This is an address of P, which means it is address of integer, right? So this is name of integer pointer variable, and this is value of P, and this is address of P. All right. So now in the RAM, what will happen? Somewhere this address of X is 200. Somewhere that 200 will be stored. Okay. So let us say this address is 1000. Each of these can have subscript A. These are addresses in the RAM. This can have subscript AA because this is address of address. All right, this is 200 subscript A, and its name is P. So this 200, because we know it is address of something, it will be basically pointing to X. All right, so that is what is happening. And how is it pointing to X? Because the address of X becomes the value of P. The address of X is stored as the value of P. So whenever I want to access X, I will say star P. If I just want to access the value of P, I will just say P. It will just give me 200. But if I want to access the value stored at address 200, I will say star P, which means it will go to the address 200 and get the value at that address. What is that? 5. Okay. So in this example, so in this example itself, P is 200. Star P is 5. Okay. I'm not assigning. This is not programming assigning. Basically, P's value is 200. Star P's value is 5. Okay. Or let us say P is equivalent to 200. Star P is equivalent to 5. That is what is happening. Clear so far? Okay. So now say let us write another function, another example. Of say squaring, not one integer, but say 2 integers. Otherwise, if we use one integer, you don't need to use pointers. You just square that value and return that value. That copy will be stored in some other variable in the main function. But we want to look at a scenario where you cannot return a value at all. So let us take 2 integers, square them and return them. Okay. So let's change the name to square. Yeah, we are passing 2 integer addresses. All right. And so now I want to square A, not A, sorry. I want to square the value stored at A, which means I'm overriding that value with its square. Similarly, I want to store I want to square the value stored at address pointed to by B. All right. So now how to write it? one simple way, let's imagine, normally, suppose if you are passing x and y, if I have to square each of them, what do I write? I have to square x. What do I write? X equal to x into x, right? Now I'm not passing x and y. I'm passing their addresses. So I don't even have names called x and y. The function only has names of pointers. It doesn't know the name of the location which this pointer is pointing to, right? It can access that location, but it doesn't know the name of that location. So even if it has to name that location, it has to name through the pointer itself. Okay. So x and y I cannot use directly. So I have to use a and b only. Okay. Now, like I said, if I have to get, when I'm saying x equal to x into x, what I'm saying, the value of x, override it with the value of x times value of x. So if I have to get the value of x in terms of the pointer, what should I write? For x here, what should I write? Star a. If I write a, it will be address of x. I should write star a. So star a will give me the value of x, right? So star a equal to star a times star a. Now you can delete this. So if you are confused how to use pointers, first think in terms of variables, then replace that with the corresponding pointer. Okay. Now similarly for star b equal to star b times star b. You need not return anything. The original variables are modified. Okay. So instead of swap, this function name is square. All right. Function for squaring. Before squaring, after squaring. All right. In this case, I passed pointer variables. I can as well directly pass ampersand x and ampersand y. Instead of this, I can pass this as well. Both will work. Fine. I need not even need these. This will also work. Okay. Something is wrong. Semicolon. Yeah. So original x and y in the main function are modified. You didn't touch them in the main function. You passed them to some function. That function did something. You came back. Original x and y are modified. That's it. Because you passed their addresses. All right. So this kind of thing. So let me. So this is one of the earlier functions, swapping function. This is a function to swap two integers by passing their values, right? This is called call by value. Here you are passing int x and int y, not their addresses. So in this case, the values are not actually swapped. You thought this function will work, but it didn't work. Only the copies are swapped. All right. This is a function to swap two integers by passing their addresses. This is called call by reference. All right. So when you are passing not a variable, but address of that variable, it is called call by reference. But when you are passing the variable itself, it is called call by value. All right. If working on copies does not matter, if that is not a problem, you can just work with copies. You can just pass the variable. But if you necessarily have to work on the original copy itself or the original variable itself through a function, then you have to pass its address, not the variable. You should not use call by value. You have to use call by reference. Okay. Yeah. So normally in the code, how do you initiate? Now for each data type, there are different pointers. Integer pointer is a data type in itself. Character pointer is a data type in itself. So these are different data types. So suppose I want to declare, say, int star p. Now this int star p means it is saying p is an integer pointer. But for this p to point somewhere, that integer should exist, right? So usually you have some integer beforehand, and then you declare a pointer and you assign the address of this integer to this pointer by using ampersand. Okay, this same one line statement can be broken down into two lines. You can say int star p, and then you can say p equal to ampersand x. Both are equivalent, but you notice here we are not saying star p equal to ampersand x. We are saying p equal to ampersand x. So when you are declaring int star p, you are not saying I am declaring an integer with the name star p. No, what you're saying is I am declaring a pointer with the name p. So you can think of it as data type like this. This p is of type int star. This p is of type address of an integer. All right. And this is the only time where star will come before the pointer without meaning as the value of the variable. It's like if you remember in array, the only time where the number in the brackets refers to the size is during declaration. Similarly, only during declaration you write int star p. In all other cases where you want to use p, you should write only p. If you use if you use star p elsewhere, it will not mean p. It will mean the value stored at the address pointed to by p. Okay. Suppose if I write star p equal to x, what it means is go to the address which p is pointing to, and in that location store this value, which is the address of x. But that is not what we want to do. We want to store the address of x in p itself, not at the address which p is pointing to, right? So you should not put star p. P will have address of x. It is quite simple. This is p. This is a cell in the RAM. I want to give some value to this p. The value of p is the address of x. So I should write p equal to ampersand x. If I write star p equal to ampersand x, this will first look at the value and see this is an address. This address is pointing to somewhere. Let me go there and overwrite that value with the address of x. That is not what we want to do, right? We want current value to be address of x. So just write p. Okay. So ampersand is basically giving us address of a variable. All right. This is also called reference operator. Star will give us the value located at an address. All right. This is also called dereference operator. Okay. Now star can go before which kind of variables? Which kind of data type? No. Star can go before only if I put star x, does it make sense? No. So star cannot go before normal variables. Star has to go before pointers only. Okay. Ampersand can go before any variable. It can go before normal variables also. It can also go before a pointer as well, because you can have a pointer to a pointer. You can have double pointers. That is how actually 2D arrays are implemented. Whatever 2D arrays you learned using brackets, those use double pointers. 1D arrays use single pointers. You can have multi-dimensional arrays, 3D arrays, 4D arrays, any level of arrays you can have. All those are implemented using those many levels of pointers. Triple pointer, 4-level pointers, whatever. It's basically star star p, star 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 p, and so on. Okay, so you can ask for address of a variable, or address of a pointer, or address of a pointer to a pointer. All these you can do. Those will be useful sometimes. Usually we just deal with address of variables, because usually we deal with single pointers. But when we deal with double pointers, we also need to deal with address of single pointer. Okay, but star will always go only before pointer. It can be single pointer, double pointer, triple pointer, but it should be a pointer. Only before these kinds of pointers or different levels of pointers you can use star. You cannot use star before a normal variable, before a primitive data type. You cannot say star of a character variable or star of some integer variable. Normal integer, you can't put a star before it. Normal character, you can't put a star before it. If you put star before it, it will be treated as multiplication. Just normal multiplication. You see, this is called operator overloading. You might have seen this. If you, I believe many of you are familiar with Python. In Python, when you write a plus b, if a and b are numbers, it is treated as addition. But if a and b are strings, it is treated as concatenation, right? It can't add two strings, right? So what does it do? It will concatenate them. Okay. So depending on the operands, the meaning of the operator changes. If the operands are numbers, plus is treated as addition. If the operands are strings, plus is treated as concatenation. This is called operator overloading. Same operator will get different meaning in different contexts, depending on the environment. Similarly, star operator, if you are putting it before a normal variable, it will be treated as multiplication. If you are putting it before a pointer, it will be treated as dereference operator. Okay, so that is the difference. All right. So so if we take these both operators, what will happen is, suppose I have two variables. If I put ampersand before x, I will get its address. Okay, and if I put star before p, I will get its value. Hello? What? If I put star before p, I will get the value stored at p. So that is how you convert from one to the other. All right. Yeah. So now let us say work out one more example. Say suppose I want to just say very simple one. Suppose I just want to double a variable. All right. So double is a keyword, so I should not use that. Let's say triple. All right. It will take just one or two values. Let's say both the integers I take, I'll triple them and return. All right. So what should I write here? Star A is equal to 3 into star A. That's all. It's like x equal to 3 into x. Just replace x with star A wherever x is there. Similarly for star B. All right. So before tripling, after tripling. That's it. So let us see. That's it, right? All right. Now, so when you are dealing with arrays, what you're actually doing is you are dealing with pointers. Any array name is the address of the first element of the array. That is what an array name is. So suppose if I have say a of 5 equal to whatever, say 10, 11, 12, 13, 14. These will have some addresses. Say this has address 200. This has address 204, 208, 212, 216. Each of these are addresses, right? Because they are stored in consecutive locations in the RAM, right? There cannot be gaps between them. Yeah. The address of the first element is all you need, and the size of the array, right? Size of the array you give separately to the function anyway. Address of the first element you give separately to the function. So that is what you are passing when you are passing array name and the size to a function. Okay, so suppose I have function which says just add all the elements in the array. What do I pass? A in brackets, and I also pass size of the array, right? So when I am passing A, what I'm actually doing is I am passing this address 200. So this int A, it is not integer, it is integer array. This is equivalent to passing a pointer. Okay, so A, what it is doing is A is a pointer to the first element in the array. First element value is 10, but its address is 200. This 200 is stored in a location in the RAM, and that location name is given A. So you can actually access, that is why you are passing the array name. So suppose I'll just quickly show a code, add int star p, okay, and int size. All right. Now for int I equal to 0, I less than size, I plus plus. First, let's define sum, or no need of sum. Okay. Right now we are not modifying the array, so it doesn't matter. You can return the value or you can print the value within the function. It doesn't matter. Right now, I'm taking a very simple example. I'm not modifying the array. In this case, anything will work. So let's say int sum equal to 0 and keep doing sum plus plus, right? When you come out of the loop, you just print sum. All right. Now, let us say a of 5 equal to 10, 11, 12, 13, 14. All right. Function for adding. Add. So here, what do I need to pass? A and size 5. That's it. I need not print anything because print statement I gave in the function. All right. We did that, right? Sum plus. Sorry. Sum plus equal to A of I. All right. Yeah. Sum plus equal to P of I. We can do this also. Okay. Yeah. This is correct. Okay. Now, earlier what we used to do? Earlier, we used to give like this, or a, whatever it is. Same thing. Instead of that, you give a pointer, because a is nothing but a pointer to the first element of the array. So when you are passing an array, you will never pass an array using call by value. Inadvertently, you have to pass an array using call by reference. Even if you want to pass an array using call by value, it will not take. Such a provision is not there, because if you want to pass an array using call by value, all the elements should be copied. If an array is of size 1 million, it should copy all the 1 million elements just to add them, or whatever functions it wants to perform. But why copying? You just copy the address of the first element of the array and act on the array. But here the point is, you cannot avoid acting on the array. Whatever changes you make, that will affect the original array. You can't act on the copy of the array. If you want to act, you make a separate copy in the function and then do that. But when the array is passed, it is passed by reference only. That's it. All right. So we will discuss this in more at length in the next lecture. But I hope you got the idea. You need to work out some more problems to understand pointers. This is a tricky concept.